You know that thick, gray blanket that can just roll in and completely transform a landscape into something, well, something mysterious. It shows up without a sound and can disappear just as fast. So what exactly is fog? Let's dive in and really understand this amazing atmospheric marvel.
Have you ever stepped outside on a foggy morning and felt that damp chill, and it feels like you've literally walked right inside a cloud? Well, guess what? You basically have. And that feeling, that's the key to the whole thing.
Because really, the simplest definition is right there. Fog is just a cloud that's touching the ground. Physically, there's no difference between the stuff up in the sky and the stuff surrounding you on the street. The real difference is all about how, and more importantly, where they form.
So, clouds usually form when a pocket of air rises way up into the atmosphere. It expands and it cools down. But fog is born right down here with us. It happens one of two ways. Either the air at ground level cools down to the point of saturation, or extra moisture gets added to it. Two different paths, but they both lead to that same beautiful and sometimes hazardous result.
And yeah, while it can be absolutely stunning to look at, it's not always harmless. Fog is officially considered a hazard, and for a good reason. It can slash visibility down to almost nothing. When it gets really dense, we're talking less than a kilometer of visibility, which makes driving, boating, or flying incredibly dangerous.
To really get a handle on fog, we've got to break it down into different types. So first up, let's talk about a group we can call the cooling crew. These are all fogs that happen when the air temperature drops all the way down to its dew point. That's kind of the magic number where the air just can't hold all of its water vapor anymore.
The first type is radiation fog. And honestly, it's kind of like a recipe. You need a few key ingredients. First, clear night skies. That lets the ground radiate its heat away into space and cool down fast. Then, you need high humidity, so there's tons of moisture in the air ready to condense. And finally, you need calm air, or maybe just a super light breeze, to keep that newly formed fog from blowing away.
But what's really cool is how it disappears in the morning. We always say the fog lifts, right? But that's not actually what's happening. The sun comes up, it warms the ground, and the ground then warms the layer of air right above it. This makes the fog evaporate from the bottom up. It's less like it's lifting and more like a curtain being raised from the floor.
All right, our next member of the cooling crew is a real celebrity in the fog world. I mean, if you've ever seen one of those iconic photos of a thick blanket of fog just pouring over the Golden Gate Bridge, well, you're looking at advection fog.
And the name comes from a pretty simple weather term, advection. It just means air that's moving horizontally, side to side. And that movement, that's the absolute key here.
See, advection fog happens when warm, humid air moves sideways over a cold surface. For San Francisco, that's warm, moist air from the Pacific blowing over the chilly California ocean current. The air gets chilled from below. Its temperature plummets to the dew point, and bam, you get that thick, stubborn fog that can just swallow the coast for days on end.
The last member of our cooling crew is upslope fog. And just like the name suggests, it forms when humid air gets pushed up a landform. Now, this doesn't just happen on huge, steep mountains. It can actually happen over really gradual inclines too, like across the Great Plains in the United States.
This happens because of a process called adiabatic cooling. I know, it sounds super complex, but the idea is actually pretty simple. As air moves to a higher elevation, there's less pressure, so the air expands. That expansion uses up energy, which makes the air cool down. And if it cools all the way to its dew point, you guessed it, you get a massive layer of fog.
Okay, so that was the cooling crew. Let's totally switch gears now and look at our second category, fogs that are made not by cooling the air, but by adding more moisture to it. Let's meet the evaporation duo.
First up is steam fog, and this one is so easy to picture. It looks exactly like the steam rising from a hot cup of coffee on a cold morning. It happens when cool, dry air moves over a warm body of water, like a lake in the fall. Moisture evaporates from that warm water into the cold air, and it instantly condenses into this beautiful wispy fog that seems to rise right up. So you see how steam fog is basically the exact opposite of advection fog, right? With steam fog, it's cool air moving over a warm surface. With advection fog, it's warm air moving over a cold surface. That simple temperature difference, it's everything.
And the second evaporation fog is frontal fog. You have definitely been in this one. Think about a dreary, drizzly day. This fog forms when rain falls from a layer of warm air down into a cooler layer of air near the ground. As the raindrops fall, they actually evaporate, adding just enough extra moisture to that cool air to saturate it and create that thick, damp fog all around you.
So we've covered the how, but what about the where? Where is fog most common? And just how tiny are the little droplets that make up this whole phenomenon? Let's zoom out for a couple of really fascinating facts.
So, any guesses? Go on, take a shot. You might think, okay, maybe San Francisco, right? Or somewhere in New England? Well, the actual answer might just surprise you.
The foggiest spot in the entire U.S. is a place called Cape Disappointment in Washington. It gets on average over 2,500 hours of fog every single year. Let that sink in. That's the same as 106 full days spent entirely inside a cloud. You know its name, Cape Disappointment, suddenly makes a whole lot of sense, doesn't it? And for our last fact, let's talk about just how small we're talking here. The tiny water droplets that make up fog are absolutely minuscule. An average one is only 20 micrometers across. Now, to put that in perspective for you, a single human hair is almost 4 times wider.
And that brings us to an absolutely mind-blowing number. For just one of those tiny little fog droplets to get heavy enough to fall as a single raindrop, it has to increase its volume by 1 million times. 1 million. That's the incredible journey from a floating speck of fog to a drop of rain hitting your head.
So there you have it. Fog isn't just one thing. It's this whole family of fascinating weather events. The next time you find yourself walking through that gray mist, just pause for a second and think. Is it a clear, calm night? Is there warm air blowing over a cold ocean? Are you walking up a long hill? Now you'll know exactly what kind of cloud you're really in.